Welcome to our final stat class. So not going to really be a class today, just mostly like a office hours type of meeting in case you've got some questions getting ready for the exam or your homework, which is due tomorrow. So I can kind of walk through the content on the exam at least. And if you have any questions about generally about the exam or any specifics about the content, happy to answer those. So exam 3 is going to be on Monday. Just be sure you've got the right date and time. So it's going to start at 2. It's going to be on Zoom in the usual room here. And it's going to be about as long as the previous ones. So it's not a final exam. It's going to focus on, or it's going to be on chapters 6, 7, and 8. So it'll be first part, multiple choice, second part, show your work. Same sort of format as the previous ones. And on this one, you certainly will need to use a calculator. Obviously, when we're finding confidence intervals and hypothesis tests, that involves calculation. So you can either use R as your calculator. You can use a calculator. You're probably going to want to use R during the exam just because the t-test and the prop test commands are pretty convenient. So I think I'm not going to ask you to hand in an R markdown file. In fact, you're not going to be able to do that. But when you're using R on the exam, I'm just going to ask you to say like, well, what did you enter? And you'll kind of write out what you did and then write out what the output of that is. So just be prepared to use some R on the exam, but I'm not going to collect it. Most of the formulas that you'll need in R will be like one-line things. So it's not going to be like a big simulation type of thing that was on the last exam. So I'll actually want you using, doing the calculations and telling me what you're getting. So just to kind of walk through what we've done since the last exam, in chapter 6, we did estimation methods, maximum likelihood estimates, method of moments estimates. So be sure you look over those. Towards the end of that chapter, we also talked about ways of comparing estimators like bias and efficiency and these other things. That stuff will not be on the exam. So the exam is going to be on the first 2 sections. So section 1 was the MLE, and section 6.2 was the method of moments. And the kind of properties of estimators, that was in section 6.3. Again, that's not on the exam. And then, we went into chapters 7 and 8. And so chapter 7 was all about confidence intervals, constructing them and interpreting them. And so for each of these, for confidence intervals, I would be sure that you can do a confidence interval for a single mean, single proportion, difference in 2 means, difference in 2 proportions, and as well as match pair difference in means. So these were the main types of parameters that we were estimating. And the same goes for hypothesis tests. So I would be sure that you're able to do a confidence interval for each of these types of parameters and be sure that you're able to identify which case you're in. So, just recall about whether you would want to use a normal distribution or a t-distribution when you're doing these. And again, that kind of depends on whether you know the population standard deviation or not. And so we kind of talked about the kind of streamlined ways of doing this. Right, when we put that conf at the end, that will tell us what the confidence interval is. And we also had prop tests, so I would be familiar with how to use these commands. both for confidence intervals and for hypothesis tests. But you should also be prepared to construct these kind of going through the steps, meaning, showing how you calculated these values, using Q norm in Qt, for example, showing how you calculated the standard error, showing how you calculated the margin of error, that stuff. So be sure you're practicing doing the calculations yourself as well as using these formulas. And just remember, this t-test formula can't be used if we only have like the summary of the sample. T-test can only be used if we have the actual raw sample data in R already loaded up for us. So this might not be available to you if I give you the summary statistics. If you have a data set in R that you need to work with, then that might work. The prop test, we don't need the data for, we just need to enter successes in the number of trials. So the prop test we can always get to work. Any questions about that so far? With proportions, I'll just say we did different confidence intervals, right? We did the Agresti-Cole, we did the Wald confidence interval, and we did the scored confidence interval. So definitely be prepared to construct the Wald confidence interval. That you have to do by kind of intermediate calculations. R doesn't do that one for you. The Agresti-Cole you would also need to do yourself. R doesn't do that. You might recall that there was like a Wilson score confidence interval, which was like that real gnarly looking formula. That I'm not going to ask you about. Just know that the prop test gives you that score confidence interval. So what might be helpful for you would be able to, really what you need to do each of these confidence intervals is to figure out what the standard error is. And the standard error is calculated differently depending on which of those situations we're in. But the one thing that is the same in all of these cases is that our confidence interval we get by taking the statistic from our sample and then going plus or minus Z alpha over 2, or I'll just say, I don't know how to write this in here, that this might be T alpha over 2 if we're working with means and we don't know the confidence interval. We don't know the population variance. Okay, any questions? Yeah, and so I think otherwise on these points we've pretty much talked about. We didn't use tables this semester, so you can kind of ignore any reference to tables. We use the Qt function instead, since we're using R during our exams. In some semesters, when we're in person, we use the table since we're not allowed to use computers during the exam. Okay, so that was the gist of it in, so 7.1 focused on means, 7.4 focused on proportions. I kind of summarized all of that up top together. And there are some things in 7.1 that we didn't get to, so you can kind of disregard those things. We didn't talk about that at all. And, what you also want to keep in mind here is thinking about how you interpret them as well. So just remember when you're interpreting confidence intervals, we attach first of all, what we're trying to do is approximate some unknown population parameter. And when we state the interpretation of that interval, we should attach that uncertainty, that chance to the interval and not to the parameter we're trying to estimate. So we say, for example, there's a 95% chance that this interval is going to contain the population parameter. So if you do have any questions, I think my volume is on. Please feel free to ask or chat them in as well. Okay, and then lastly, we talked about hypothesis tests, and the stuff in red was just the stuff that we've covered since the last exam. So I want to make sure that you, excuse me, since the homework assignment. So for example, rejection regions weren't on the homework assignment, but we just talked about them on Monday. But as far as hypothesis tests go, just kind of know the general setup, which is how we state the hypotheses. We spent a lot of time practicing that. How we can calculate the test statistic, what the test statistic tells us, how we can find p-values from the test statistic and make a decision based on that p-value. And now we can also throw in how to find the rejection region and make a decision based on the rejection region. Questions about that? And similar to the kind of main cases that we had before, like single mean, single proportion, et cetera, I would be sure that you're practicing doing a hypothesis test for each of those cases. So that's like 1, 2, 3, 4, and 5. So on your homework assignments, I tried to kind of mix in each of those more or less when you were practicing these. So really, in all of those cases, again, if we're doing a mean, then the test statistic is just going to equal how many standard errors was my sample from the null claim. So this mu sub 0 is denoting the null claim. So as with confidence intervals, you should be able to find p-values, rejection regions by kind of going through the steps, showing the intermediate work, or by using the same functions, t-test and prop test, to do them as well. So I'll be sure that you're practicing both of those methods. And then after we talked about hypothesis test for 2 populations, we then, last couple of classes, we're talking about type 1 and type 2 errors. So I would just be sure you're familiar with those definitions, being able to identify what they would be in different contexts, that sort of thing. And then lastly, we talked about the power of the test. So just to kind of summarize these things over here, right? A type 1 error is a false positive. So if we want to calculate the probability of making a type 1 error, right, this means we reject the null hypothesis even though the null hypothesis is true. So these are kind of conditional probabilities. And this is oftentimes denoted with alpha because this is related to the significance level. Maybe I should write it like this. So when we do hypothesis testing and we decide the significance level, what we're picking is what is the maximum amount of type 1 error that we're willing to accept. And so for type 2, that's the reverse of this. So that's when we make a mistake, false negative, when we don't reject a null hypothesis when we should have. So we don't reject it when we should have, when HO is not true, which is the same thing as saying that HA is true. And this we denote with beta. And then what we talked about last time, where we ended things, was talking about the power of the test. And it's the converse of the type 1, or excuse me, of the type 2 error. So once we know the probability of a type 2 error, which is the probability of making a mistake when HA is true, we can then calculate the probability of correctly rejecting the null hypothesis. So, and that's where we kind of left things for the semester. So that's a quick run through of the topics, and this is posted up online. And along with this, I want to just also point out, I put up some practice problems. I'll just open those up. Sorry, this is a bit slow. That's the same document. And I just kind of tweaked those questions just slightly yesterday when I was putting the answer key together. In that I added 2 parts here just to add in some stuff about rejection regions. And I took out this because it talks about the table, which we didn't use. So you can kind of, if you're curious, I'll leave the solution up there, but you can disregard F. But B and C would be good to practice since that was not on your homework. So there are some questions over here. Again, type 1 and type 2 error type sort of questions were not on your homework. So these would be definitely good to practice to make sure you're comfortable with those. And the answer key is up in the files. I haven't added a link to it, but I'll add a link to it in that exam module so you can see them there as well. Yeah, and definitely practice some of the rejection regions stuff as well. Yeah, and over here, you've got a couple estimation problems and confidence interval hypothesis test. So this is not an exhaustive list of things. It's just a couple of examples to get you practicing. Okay, so rest of the time is however you guys would like to spend it. So if anybody has any questions, general, specific, feel free to unmute yourself, ask away, chat them in, whatever you prefer. So if there aren't any other questions, I wasn't planning to do anything beyond take some questions from you. If they come to you later, I do have office hours tomorrow from 10:30 to 11:30. And you guys, whoever is here is welcome to hang around. So you're asking about question 4, is that right?
Yeah.
This one over here? This one, is that right?
Yeah.
What we're testing is this difference statistically significant? This difference being this proportion compared to that proportion. So here what we're looking at are proportions of people that support same-sex marriage based on what region in the US they live in. So this is a difference in 2 proportions, and so you're trying to set up a hypothesis test for those. And so so setting up the hypotheses, that was okay?
Yeah. So setting up hypothesis means us to input the x1 and x2, right?
So the hypotheses would be HO and HA. So these are claims about the population parameter. In this case, the difference in the proportion of all people in the Midwest that support it compared to the proportion of all people in the West that support same-sex marriage.
What if we use our prop test and we need to input the number
Yeah,
of,
so I
yeah,
think you're thinking about what happens down over here then, right?
yes.
Yeah, so when you're doing a prop test on this, and we're doing it for a difference, we're comparing two independent populations. First, we enter the successes as a vector or an array, and then we enter the sample sizes, and then possibly some stuff about the alternative hypothesis and so on. So yeah, so you need to find out what these values are. So we're told how many people are in each of them, right? So we should have like something like that. And your question is, well, how do we figure out what these values are?
Should we round them to integers?
Yeah, that's right. That's right. So for example, X1 would be the number of that. And yeah, we're told it's 62%. The Pew Research Center, they rounded that proportion off. So we actually don't know the exact proportion, but that's right. If you take 62% of 552, what do we get? I don't know if you remember what you got for that.
342.24.
Okay. So you get this. And yes, probably what happened was there were 342 people that said they support it, which came out to like 61.8%, and they rounded that up to 62%.
Okay, okay.
Yeah, so then you can just plug in that. I suspect this might even work if you plug in a decimal. I don't know if R will yell at you and say it only makes sense if you have an integer, in which case, yeah, I think you should enter an integer for something that has to be an integer. Yeah.
No, it works. And is that okay that my answer and the prop test output are different?
You mean when you did it using this method up here, like using the central limit theorem?
Yeah.
Um, yeah, I mean, the p-value that you get is going to be a little bit different. That's right. Since when you're using this central limit theorem, we did it without doing the continuity correction. If you did apply a continuity correction, which again is not something that I would ask you to do because it's not something that we did, but if you did a continuity correction, that will get you much closer to that. So yeah, your answers will be off a little bit. It shouldn't be like drastically off, but it will be different. You're right about that.
Okay, okay, I get it. And I have another question about number 6.
Okay.
Also about the t-test. When I run that test, I get a degree of freedom 22.1, I think.
Okay, so let's see. Okay, I'm trying to remember what this data set looked like. Was this a matched pair or were they not matched?
They're not.
There were like there were a bunch of, it wasn't like each brand compare a lager to an ale. It was just here's
No, it's not.
Okay, so here's the difference in two means. Okay, yeah, and so when you're doing the t-test here, since this data set does exist and it's in that resampled data, Right. So for the t-test, you would enter kind of what is the numeric variable that you're testing on, which in this case seems to be whatever they might be calling calories.
Yeah.
And then you enter how are we going to split this into categories,
By type.
which in this case is by, I don't know what the variable name
Type.
is. What is it?
Type.
Type. Okay. Yeah, so you would enter this, then you enter the data set. So you would say data is AL logger, and then any other things that you might need to adjust. Like I don't think you would need to adjust the null hypothesis because it's going to assume that it's 0. So that's fine. And then depending on your hypotheses, you might need to indicate what type of test you're using.
Yes. So the output is it has the information of this test, and it's that the degree of freedom is 22.261.
Mm-hmm.
Does that seem right?
Yes, it does seem right. Yeah, that seems like a weird number. When you do this t-test, keep in mind you're going to get some test statistic, which is going to be like mean 1. If you were doing this by hand, at least um, over this, right? And that standard error formula is a bit complicated when you have two means, but we've got a formula for that. And so you find the test statistic, and then you need to use a t-distribution to figure out what is the area, in the tails beyond that test statistic. And the degrees of freedom here, there are different ways that people estimate that. And so when we were doing these by hand, we were just saying we take the smaller sample size and subtract 1. And when we use this as our degree of freedom, I'll just say over here that we are erring on the side of caution. So we're giving, we're building more error into our estimate than we actually really need. And so there's a formula called Welch's formula to approximate more accurately how many degrees of freedom we can use. It's a horrible looking formula, but according to that, it's saying it's 22 point something or other, and that's a more accurate thing. So all it's saying is, the test statistic that you see from the output should be the same as the test statistic that you would calculate by hand. The p-values are going to be a little bit different because when we were doing it by hand, we were using this many degrees of freedom, but when you use the t-test, you probably see somewhere in that output that it used Welch's approximation formula to get the degrees of freedom.
Oh, I see. I see. Thank you.
Yeah. Yeah. So, yeah, again, like whether you use this or this, it's not gonna, like, the difference is not gonna be humongous. There'll be some difference, but it should be pretty small. Thanks everybody for a really nice semester. Good luck with finishing up your classes and projects and other exams the next couple days. And I'll see you guys on Monday. If you do have some questions over the weekend as you're getting ready for the exam, feel free to email them to me. I'll be checking my email, but if you get them to me like Sunday night, I probably won't be able to respond in time because I have a meeting on Monday morning, so I won't be able to respond to email on Monday morning before our exam. But if you get them to me by Sunday afternoon, then I'll have a chance to respond on Sunday. So just keep that in mind. Yeah, otherwise, yeah, great. Nice meeting you all. Nice seeing some of you again. And hope for those that are going to be around next semester, I hope I actually can see some of you in person in the math department.